Hi there, my name is Jason Wilson. I've been an HVAC tech for about 9 years now, working with Facility Plus, doing a lot of their maintenance on the rooftop units, as you can see here. This guy here is a Terrain unit, which is a very well-made brand. It's been around for a long time. I think they have over 30 years in the industry. And this guy in particular we're working on is a 7.5 ton rooftop unit. It's a high efficiency, very high efficiency model. This one has variable frequency drives, so just improves efficiency all around for your building and for proper cooling and for heating. You save costs on electricity down the road on these particular models, and we'll walk you through kind of the maintenance and the do's and don'ts and what to look for when doing maintenance on these machines. So we'll start off just doing a visual inspection of the unit, taking a look. First thing I like to do upon inspecting the unit is I'll take a look at the gas lines, natural gas, making sure that everything is painted and everything is to code. You have to make sure you have your gas shutoff valves, your roof supports for the system. They're usually spread within 4 feet to 5 feet apart, depending on the size of the piping. We also do inspections just on the way the unit is sitting. Make sure it's all level and that there's no issues with it off level, because that can affect the performance of the unit. This particular unit has been retrofitted. It was designed with a different roof curb for a different brand of unit. So that's why you're seeing the curb adapter. These curb adapters are crucial for the efficiency when you do retrofit to another brand, because the ductwork changes configuration. So you have to have these. And you have to also make sure that these are also level when installing them. Then we just do a quick walk around of the unit, make sure that our electrical disconnects are in check and they're not rusting out. No wires are exposed. We just check that, make sure that is good. This unit, as you can see, is running right now. It's everything looks good there. Wire is tucked away within the unit, and all the supports are in place to hold that wiring so that it doesn't not flailing around. We do a visual inspection of these coils, and this is for the air conditioning side, making sure that the fins on the coils and that everything is the way it was from factory. They're not bent, no birds have hit them, because that will affect the efficiency of the cooling capacity on these units if the fins are bent in any way, shape, or form. If there was a situation where they were bent, we have a set of combs that can straighten out the fins, providing we do a quick visual inspection, make sure there's no damage to the actual refrigerant lines within those coils, because that's what provides all the cooling effect. And we walk around, crucial part of an AC system, and in this case, this unit's running on air conditioning, as we're in the middle of the summer, is the condensate trap for the evaporator coil. This is a crucial maintenance tip that you must make sure on every maintenance for a cooling season, that you're cleaning out those drain traps regularly. You'll usually snake them clean, make sure that there's no debris, no sediment in them, and then we go one step further when we're inside the unit, looking at the drain pan for the evaporator, make sure it's all cleaned out and there is no sediment sitting in there that could cause this to back up and spill water over top. Then we come around this side and we just do a quick visual inspection. This is the fresh air hood, and it's also for the economizer. We want to make sure that these inlet screens down here are very clean and there's no debris, nothing blocking them from bringing in air or trapping air getting into the unit, and that also increases the efficiency of these units when they're operating. So we're just going to start on doing the maintenance for the cooling side. Upon walking up to the unit, after doing our visual inspection and addressing anything there, we'll start just by opening up the control panel side, making sure that we have a visual inspection of the control board, and then make sure we're not seeing any errors on it. And if that checks out, we will move on to the next step. Okay, so we open up that, and now you can see this is the main logic control board, and it's a programmable logic control. These are fully upgradable. You can do diagnostic from these boards. They'll tell you majority of the time what's going on with the unit, how its efficiency is, if it's running at full capacity, at full efficiency. If there's any issues with the unit, it pretty much diagnoses and summarizes it on the board for you and tells you. And if you plug in a laptop to it, you can one step further, get further diagnostics just on a bigger scale, and it essentially will break down the whole unit and tell you what it may need, what it's been doing. So it even gives you a report for the last, depending on the few months prior, how it was running versus now. So take a look at it, see if there's any error flashes on the board. Right now, this thing is it's just the regular heartbeat, which is a good sign. That's typically an indication that you have no issues running on the unit. And we just check it out. Yeah, so it's a standard operation, no issues there. Then we just, this is on the low voltage side, okay? So this is your 24 volt side, which is your thermostat, would control this. When you get into bigger systems, they'll have building automation, and those are a little bit more complicated, but they all kind of run into these programmable logic boards. The high voltage side, before I shut it down, I'll just come over here so we can do our proper maintenance, and we'll shut the unit down, disconnect the power. So I would just like to close that, and you hear everything shut off. And we'll come back over here and just take a quick peek. We do a visual inspection of the high voltage side. Make sure we don't have any pitting in the contactors, no arcs in the unit that could be causing a short, especially on the contactors. They have a tendency to start getting rusted, and then they will short out to the cabinet. In this case, this is a pretty new unit, so it's in really good shape. No issues there. I don't see any reason for concerns. We will go through checking terminals, making sure that they're tight and that we don't have any loose connections. I typically just use a checklist for that, and we run through the checklist, checking for electrical connections and making sure they're all tight. Nothing is loose. The last thing you want is a loose wire causing the unit to short out or it causing any burning. Transformers, everything's good there. Yeah, these are all nice and tight, no issues there. So that's the electrical side. On the high voltage is good. No reasons for concern there. And if we did find something, that we would always log that and send that back to the customer in the report. And this is just a safety panel for the high voltage side. When the unit's running, if you're checking the board, you don't want to get your hands caught up in there because that would be a potential problem. So now that we've checked the electrical, we go through our major cooling checklist, which I have on this phone. And this will give me a complete checklist of the things that we're going to be checking for our maintenance programs, whether it's cooling or heating, and whether it's major or minor maintenance that we're performing. So in this case, we've checked the electrical connections. I would just check the box. We've made sure that we have the proper voltages. We saw that on the board. Check that. And then we just go through the list. I'll start to open up these panels, and then we'll just kind of break it down and go through it as it goes. First panel. We're going to look at, the first thing is we're going to check is the filters. We always go through the filters. When you walk up upon one of these units, you want to look at these dates. Usually a good tech will date the last time when they installed new filters. So we check those dates and we try to see, okay, how often are they doing their maintenance? Are they doing it within the right timelines, or are they waiting too long? In this case, these ones aren't bad. So we did these back in June. So we're still pretty good. Yeah, we take a look at them. You would want to put them into the light and make sure you can see light through them. These ones are still pretty good, and this is a kind of a dull day outside, but you can still see the light through those filters. So these aren't bad. We would probably change these coming up into when we do the fall maintenance. So right now we're still in the summer. So when we get into the fall, for the heating side, we'll most definitely change these filters out. Filters are, in this particular unit, we have, there will be 6 in here, and we would replace all of them. And the reason we do that is just to make sure that you're getting clean air coming in from the return side of the building, and it's being filtered before it goes through the coil. This is crucial on the AC side, mainly because if you have dirty filters and you're restricting airflow to this coil, this is the coil that's providing all the cooling into the building. The refrigeration system, which is these lines that you're seeing here, are providing the cooling effect to this coil. If they cool this coil to what they're supposed to, and you're not getting proper air filtration coming through these filters because they're clogged, what's going to happen is this coil is going to ice up. It's going to become a big block of ice because it can't relieve any of the cooling down into the ductwork, and you get ice blocks onto the coil, and then you'll get a massive, typically you'll get a leak, or you'll get a no cooling effect within the building. You won't feel any cooling coming out because you have a big block of ice on the coil and you can't get any air through it. So these are things that we do. Maintenance is crucial for the AC side, and making sure that the filters are always clean. A lot of customers don't realize that, and they'll prolong changing filters, and that will drastically affect the efficiency of these machines and the lifetime and the expectancy of them. So it's always best practices to make sure that they do that and change them regularly. Okay, I do a quick check for the cooling maintenance for the economizer, and we make sure that the economizer is working properly. We go through that, and there's a mechanical motor that will open and close that economizer based on the requirement, the need, the humidity outside. So we these are all factors that play into the refrigeration systems. They're very complex systems. Typically a refrigeration mechanic or an AC mechanic is the guys that will be looking into these more in depth. Most HVAC maintenance guys, they'll usually have their AC license to do that type of work, and if any repairs are required, they would do that. We do a quick visual inspection in the electrical components, and these are just another control board for the economizer system, which all plays into the efficiency of the AC cooling. After we've confirmed the filters are good and gone through some of the systems, the AC systems on the evaporator coil side, I just go through my checklist again, and I'll check off filters have been checked, replaced, or giving a report on the condition of them using this software tool. We also take pictures, so I would take a visual picture of the filters just so that we have it for a reference, that it shows when we did the maintenance, and that everything checks out. Okay, so now going down the checklist, we're just checking for any linkages that might be loose or need tightening. We check, crucial part of it is the blower assembly. You want to make sure that the blower assembly is spinning freely and there is no loose connections, bolts, belts. You want to make sure that the belts are tight. In this particular unit, it's direct drive motor to the blower squirrel cage, which means there is no belt assembly that turns it. So you don't have to really check any belts, but in this particular case, you still want to check and make sure your motor's running freely. We do a quick check looking at amp draw on the unit and the motors, the blower motors, make sure they're running efficiently, and they're giving the suggested manufacturer specs for what the amp draw should be when the unit's operating. So we go through the AC system, and then we're doing an inspection on the compressors. We're just making sure, again, no loose connections, everything's in there snug and tight, and all the wires are they're nice and tight together, not flailing around where they can be pinched, especially when we're putting on any panels back on. Then we'll just go through and look at some of the welds, make sure there's no signs of leakage. You'll sometimes see some staining on the copper lines, and that if we did see that, we would take a visual note and pictures of that, and then we would have to complete a check on the pressures and check that. We also would, through minor or major cooling maintenance, we'll check pressures on these units, make sure that they are at the manufacturer's suggested refrigerant pressures and their operating pressures are right. So after we've done that, we just go around the unit and we'll check again. We do a visual inspection on these coils. In this case, the panels are covered on this one. I've already done this one previously, but we can show that on one of the other units. We would check the fins on the condenser coil, make sure that there's no bends and no damage to the coil, which could affect the efficiency of it. And once you've done that visual check, we would check that off on our checklist and on to the next thing, which would be we'd come around the back side and then we would just check our drains. We just snake that guy clean, make sure all the debris and sediments out of there, and then just give it a tap. And then the same thing in here, come up in here, and we just kind of brush it out, make sure there's nothing clogging in there or binding in there. So now that we finished our condensate drain trap cleaning and the pan cleaning for the AC side, another part of the major cooling maintenance on our inspection sheet is we're just going to check the compressors, making sure that we're receiving proper amp draw from the compressor and that it's adhering to the manufacturer's specs while the unit's operational. We check these wires leading in, and if they all check out, then we know compressors are operating properly. And we'd repeat the process again for this second compressor. This particular unit has 2 stages of heating and 2 stages of cooling. That's why you have your 2 compressors. So your second stage will only kick in when the heating demand or the cooling demand is very high. You have very high humidity outside. You need to get the building cool, and 1 compressor just isn't enough to do it. It needs a second and backup to do that, and that's when the second unit would kick in, the second stage compressor. So on a really hot day, you'll have both running, and that also increases the efficiency. The one compressor is not having to run as hard when it's kind of sharing the load. Okay, so now on our checklist, we also have a heating maintenance checklist as well. And what we do is we typically, upon arrival to the unit, we're doing the same process as we do when we're checking on the AC side, just a visual inspection around, making sure our venting pipes are clear. This is our combustion venting. We want to make sure there's no bees or anything in there. That is something that in the summertime, the yellow jacket bees have a tendency to try to invade and use that as a home. So we always keep those, make sure they're clean, doing a visual inspection on that. Looking inside the unit, make sure there's no bees inside this section. They tend to gravitate to this because it's a heated side. They look for heat, warmth in the fall. They don't want to die as quickly, so they come into here. So we do that, and I usually bring up some wasp spray just to make sure I can deal with them while I'm up here. We take a quick look at the burners, make sure there's no corroding on the burners, no rust. We'll do a visual inspection of the gas valve, the terminals on the gas valve, making sure that they are all in check, nothing's loosened off, everything is tight. We just kind of look through the wires and check that. We'll take a look even at so we have a spark igniter and a flame sensing rod. Those are some of the common service related issues when it comes to the heating season. When your unit's not working, you're not getting heat, it's usually because you're not either getting a spark or your flame sensing rod's not noticing, it's not reading the flame because it's either damaged, it's got debris on it, surface rust, and it can't properly send the signal to the board telling it that it senses a flame. So it never actually leaves the flame on. It's a safety that shuts everything down. So these are some of the common things when you run into heating maintenance. We also check venter motor operation, make sure that that's running properly, because that has to vent your products of combustion, your CO. And that's another thing that they have a tendency to get rusty over the years. They fail. There is a capacitor on them, which is essentially like a little battery pack that helps this motor start under load. We check those because these capacitors do tend to lose their charge, and then they don't have the power to get this thing running. So that's another thing, and we can check that with our amp probe, checking the microfarad reading on that. I just go through the checklist, and it gives me all these things that I've just mentioned to go through, and then as we go down the line and check those off. When the unit's working, we will also check the flame, making sure that we have a strong blue flame. We'll even check if we had an issue where they're not getting proper heating, a complaint where they might be saying that they're getting an odor. We would want to check gas pressures and make sure that the gas pressure coming from the meter and into our valve is at the right pressures. These units, especially in the heating season, to maximize their efficiency, they have to be putting out the right amount of gas pressure into the flame for it to be efficient. Otherwise, if it's under firing, you tend to get low heating, you'll get odors, you'll get improper products of combustion, and it can lead to a whole other slew of problems down the road. One being the heat exchangers. It can cause the heat exchangers to crack. They'll leak CO, carbon monoxide, into the building, which you don't want. And then the units have to be red tagged if it's deemed that they are leaking, which is an entire shutdown of the unit. And then you have no heating until they can come up with a solution or a temporary source of heating for the building. So that's something that's in our checklist, and we go through and do a very thorough check on that, make sure everything is good there. I will bring you around to the other side of the panel. We'll open up the heat exchanger side so I can basically touch on what I was just talking about here, about looking at the heat exchanger and doing an inspection on it. And we'll go ahead and do that now. So back to the heating side, and now we're going to do a visual inspection of the heat exchanger. Make sure that that's good and there's no signs of any damage, pitting in the heat exchanger, any holes, which tend to occur when you have a low firing flame from the heating unit. Okay, so now we got the heat exchanger panel open. We can do a visual inspection of it, and we basically just go over it and just kind of give it a quick wipe. Sometimes there's a little bit of surface debris on it, dust, just that gets in there, and we just want to take a quick peek at it. Especially in the bends of the heat exchanger, that's usually the weakest points and where you'll see any type of pitting or holes. We just kind of run your fingers through there. I'll just take my glove off and just feel around. And this guy is a pretty new rooftop, and it's running really well. So it's not as rusty as when you walk up onto an older unit. They will look very rusty. When they do get to that point, you're checking them. You can use any type of surface tool just to kind of see if the metals are breaking down. You just want to make sure that it's not rusting and it's going to fall apart, and that it will stay intact so that you don't get any leak. If these have a hole in them and they're leaking, that's when the CO will leak down into the ductwork below and into the building. So you will have an issue that you need to red tag the unit and shut it down. So that's why you want to make sure this is a crucial part of the heating maintenance, that you do check these. Whether it's major or minor heating maintenance, I would always, good practice to check this. It's peace of mind for you as a service tech, and also for the customer, knowing that they're safe and there's not going to be any issues down the road. And just one other thing, as part of the cooling maintenance that we want to make sure, and what we have on our checklist, is that we're checking the condenser coil yearly in the spring, making sure that there is not an excessive amount of pollen that is trapped on the coil. Pollen will get sucked into these coils when the unit is operating, and any particulate matter that's floating around in the air. If they do get clogged up, we recommend a power wash cleaning. It is a crucial part of the efficiency of the AC side of these units. If these condenser coils get blocked up, you don't get usually proper cooling, and then what happens is the result is you'll get icing up of the coil because the unit can't reject the heat or the humidity from inside the building because this coil is not able to breathe. And then if you do make sure that you have it clean, your efficiency just stays that much better. It's as per the manufacturer specs, as opposed to getting out of whack. So that is something I strongly recommend. A lot of customers don't realize that, but cleaning these coils yearly is a very crucial part of the cooling maintenance program on a rooftop unit. Okay, so now that we've gone through the checklist and done our cooling maintenance and just touch base on the heating maintenance side of these reports and checklist, I'll go ahead and proceed to turn the unit back on. Everything, all the panels have been closed back up, and we're good to go with starting the unit back up. Okay. The unit will have a time delay. It's a safety feature on them, so it will count down on its time delay, and then it'll restart the air conditioning systems. Okay, so this is a carrier unit, much smaller unit than the train unit that we worked on earlier. This is a 3-ton rooftop unit, packaged unit, and as you can see, they are very similar. They do have their slight differences between manufacturers. They do that just to have their own unique things that they will use for sales purposes, and also even for the service side. There's some, in certain cases, you have different tools that are needed to service these units versus the train units. So we've gone through this unit. I'll just touch base quickly on the software tool for our maintenance. When we do our preventative maintenance reports, we can work either from the cell phone with that software or from the iPad, and we will use that just to kind of fill out our checklist, make sure everything is accurate, and we've gone through and haven't missed anything throughout that report.